This is 10-1, page 2, and we're going to further look at some absolute value functions, but we're going to compare them and use what we know about linear functions. So y equals negative x, it's a graph of this. And so what's going to happen is we're going to take the absolute value and then negate it. So the absolute value of negative 3 is 3, and then the negation of 3 is negative 3. And then the absolute value of negative 2 is 2. Negate it, it becomes negative 2. The absolute value of negative 1 is 1. Negate it, it becomes negative 1. The absolute value of 0 is 0. Negate it, 0 doesn't have a sign. The absolute value of 1 negated is negative 1. The absolute value of 2 negated is negative 2. The absolute value of 3 is 3. Negated is negative 3. I'm going to graph it. I have the 0. I have negative 3, negative 3. Negative 2, negative 2. Negative 1, negative 1. And then I have 1, 1. 2, 2, 3, 3, etc. The vertex is still at 0, 0, and it is a max. Conclusion. Here is the parent function of an absolute value. This is parent of an absolute value, and then when y equals negative absolute value of x, it is going to reflect over x-axis. This has a min, and this one, y equals negative absolute value of x, has a max for a vertex. Okay. Y equals x plus 2. That just means our y-intercept is at 2, and we have, we still have the linear parent function, but we moved it up 2. So now what we're going to do is negative 3, the absolute value, plus 2 is negative 3, plus 2 is 5. The absolute value of negative 3 is 3. 3 plus 2 is 5. The absolute value of negative 2 is 2. 2 plus 2 is 4. The absolute value of negative 1 plus 2, that's 1 plus 2, which is 3. 0 plus 2, absolute value is 2. Absolute value of 2 is 2, plus 2 is 4. And absolute value of 3 is 3, plus 2 is 5. I'm sorry that the graph doesn't look very nice. I always graph my 0 point first. He's kind of important. And then 1 is 3, 2 is 4, 3 is 5. Here, here, and here. So our parent has a min. A vertex is a minimum. Starts at 0, 0. When I have the absolute value of a number plus the absolute value of a number plus a constant, it is going to move up. And the vertex is still going to be a minimum. I was going to write still, but let's write just minimum. Continuing on, So if y equals the absolute value of x plus k moves up, then y equals the absolute value of x minus 2, I'm going to predict moves down. And so I am going to, y equals x minus 2 is the parent function, move down 2 spots, going through the negative 2 on the y-intercept. So this is negative 3 minus 2, which is 3 minus 2, which is 1. Negative 2, absolute value is 2. 2 minus 2 is 0. Negative 1, absolute value minus 2 is negative 1. 0, absolute value minus 2 is negative 2. 1 minus 2 is negative 1. 2, absolute value is 0. And absolute value of 3 minus 2 is 1. Like I said, I always plot the 0 value first. I see that these are symmetrical because they are the same as they go out. So 1 is negative 1, 2 is 0, etc. And my prediction was correct. So y equals absolute value of x is parent, minimum, vertex at 0, 0. Y equals absolute value of x minus a number, minus a constant, has a minimum, a vertex, moves down. And I'm going to pause the video right there in the middle of page 3.